Hello everyone, welcome again in Eng-Man YouTube channel. So today we will have another case of pressure transient analysis. So let's go. As usual, available radius 4.25 inches, and for the pay zone it's quite thick, 184 with porosity of 0.21, and the top reservoir is 2667. Okay, and we will have another multi-phase case. So for this reference parameter, I'm going to use this one, 175, and lastly for the GOR 332. Select water in addition to saturated oil. For the gas 0.7, for the oil it's 38 degrees API, and for the water it's 14 ppm. All right, interfacial tension. Okay, so I'm going to squeeze this window so I can see the OK button. I still can't see it. Squeeze again. Click OK. Relative permeability, I'm going to open this one. So for the SORW, it's 0.27. And for this one, I think it's 0.3. Click on OK. Next, formation volume factor is 1.233 with viscosity 0.722. And for the total compressibility, oil saturation it's 0.47, gas saturation it's 0.05, and for the water saturation it's 0.48. Click on OK. Check use perine. Okay. You can also use the relative permeability. A multi-phase extraction is required. We can use perine instead. Next. Okay, create. So first I'm going to load my pressure data. So let me copy my data first. Okay. So yep. And then yes, PSIG, time format points, click on load. Okay, I'm going to delete this one. This is not necessary. This is not important. And then for the flow rate, I think I need to prepare my flow rate first. So, yep, please wait for a while. I'm going to do it in my second monitor. The flow rate oil 30, and then 683 for water rate, and then lastly for the gas rate in MSCFD it's, let me check, 129. And the duration, the flowing duration, it's about 13 hours. And for the build-up, this one minus. Okay. thanks for your patience. So I've prepared my flow rate. So this is my flow rate data. And then this one, water rate. So actually the flow rate is not, it's not big. It's 30 for the oil, and for the water it's only 680. Relatively speaking, it's quite load. Okay. All right. And then of course we are going to need to perform edit QAQC. Okay, and then let's maximize on that one. Oh, you see this cyclical ups and down. I think it's gauge issue. You actually will have this issue also due to, how do I call it? Why I can't remember, but I think certainly it's about gauge issue. Okay, no problem. We can do averaging later. So first thing first. Oh, maybe we need to perform averaging first. Okay. So let me use my box. Okay, so let's try process and least square denoising. Let's try. Hmm. But it's like there is no flowing pressure. It's like it's almost like, you know, the built up pressure. So I will undo. Hmm. It's it's quite tricky. So what about using average instead? Or if not, I'm going to use, yeah, let's try average first. Still, it's like there is no difference. They are too close, I think. No? Oh, can we take it? Take it or not? Yeah, I think we can take it. So far so good. So it's okay. I'm going to delete this one. Use lasso and then delete. Okay, good. And then let's just move this flow rate. Okay, and then let's move it. Okay, so let me copy this one. It's 13.27, and this one, okay, 56. Okay, so of course use that as well for the gas. Sorry, not that one. And this one is 13.2788. And lastly, for the water, 2788. All right. So, yep. Yeah, we need to remove this one. I don't like it. So let's just maximize first and then use lasso Lasso, it's a kind of rope, right? Used by cowboys. They use lasso. Delete. Okay, and then what else? I think it's a point. No, we need to delete that. I'm going to delete this. I'm going to delete that. Okay, and then I'm going to use. Okay, and so the last point, delete this one, delete. Lastly, this one, delete. Okay, so the last point will be at this one. Okay, let me take that. So this one will be, let me, okay, so I'm going to change the, all right, doesn't matter, it's okay, because we start here from this pressure. So for the flow rate, it will be 557379. Okay, there. And then for the gas, 557379. Copy, and lastly for the oil. It's actually weird. Okay, but yeah, let's maintain it first. Okay, so far so good. So let's go to the analysis, and clear analysis, start updating. Okay, so first for the pressure, I'm going to start from 0 or 14.7, or yeah, 0 psig. Okay, so yeah, if you want to do that, you can use this panning. So the difference between the flowing pressure and the build-up pressure is very small. It means the skin will be small, but I'm not sure what happened. So let's just see, extract delta P. Okay. Yeah, we can disregard this because I think it's not representing the reservoir. Actually, we can remove that part. Oh, sorry, I click on this auto. Yeah, we can remove this one because it's quite, yeah, it's misleading. If you check the delta P, yeah, or we can take that, but yeah, we will just neglect it. Okay, because it's not reservoir property, it's not reservoir phenomena. Okay, most of the time it is operational issue. Okay, so yeah, just let's just maintain it and neglect it in our analysis. So for the production data, select oil, gas, and water. And then if you want to improve the smoothing, like this, or 1.5, or don't use too high smoothing. So I'm just going to use 0.1. By the way, it's now raining. Hopefully it doesn't jeopardize the sound. Okay, so yeah, you can see a hump here and a pressure increase here, which is not correct, but yeah, let's just neglect it in our analysis. So I'm going to use analytical. Skin is high. Wow. Vertical limited entry. And for the property, the propagation length is only 6 feet. ZW 156. Okay, and then let's try this one. Okay, and let's just improve. It should be easy. Yeah, it should be easy. And I think we got it. Panning. Okay, and we get a good wellbore storage here. Unit slope. We get a good, you know, radial flow. We get this permeability at this section at this period, which is reasonable with the data. Okay, and if you want to get the investigation radius, click on this one. You see, so around here we achieve radius of investigation of around 900. Again, this trend you can neglect. It's not, most of the time it's not reservoir issue, it's operational or equipment issue. And let's check results in plot. Let's see if everything is reasonable. Okay, so the actual, based on interpretation, actual perforation length is 9 feet. Okay, by design it's 6 feet, so in actual it becomes 9 feet, so makes sense. ZW, okay, distance between the bottom section of the reservoir with the mid perforation. So total skin, geometrical skin due to partial penetration, okay. And PI, initial pressure, okay. Permeability equivalent, it's quite high, okay. So that's why the PWF, flowing pressure, and the built-up pressure, they are very close because we have very high, very good permeability. Thickness, okay, based on data. KZKR, the vertical permeability greater than radial permeability. I do not like that, so I'm just going to use sensitivity analysis. Let's try 0.1 and model value. I'm going to limit it at 4. Okay, so right click, legend. So if the KZKR is 0.1, the trend will be like this, and we will see, yeah, the pressure will be there, and this one 0.63. Okay, so I'm going to do improvement, and then KZKR, I'm just going to limit it at 0.5, starting from 0.05, my first initial Gas value is 0.3. And yeah, okay. So what do we get? Which is still good. KZKR 0.5. Okay. All right. I think it's quite good. Okay. And let's see what we can do with this one. So if I decrease this one, okay, it doesn't, you know, it's okay. This one is still okay. But for this one, yeah, we see hump there. I don't know. I think we can try to mimic we can try to follow the hump using changing Wilbur storage. So yeah, let's use changing fair. Okay, improve. Let's maintain everything. I think permeability, okay, we can regress on that. Yeah, let's try. Yeah, a bit better. Okay, not really. Yeah, there is hump, and this is, yeah, not very good, but I think still reasonable. Okay. Yeah, this one again, we can neglect this. So let's try improve by following the history and no changing Wilbur storage. Yeah, this can happen if you stop using changing Wilbur storage. Hmm, can undo. Reset from diagnostic. Yeah, let's try again. Try it again. And analytical, vertical, limited entry. By the way, it's a vertical well. Perforation length. Yes. Okay. Sorry, it's 6. All right. Let's follow the log results. Improve parameters KZKR. I'm going to maximum 0.5 again. 0.5, 0.3. Okay. Okay, still good. Let's try. What is this pressure? 760 psia. Let's see if we can impose PI, impose initial reservoir pressure. Yeah, actually, the difference not very high actually. Yeah, I think it's reasonable. So the permeability is very high with KZKR 0.5. It still makes sense in this reservoir. Yeah, another thing we can try delete this one. Yeah, we can try deleting this one. It's for limited entry. Let's see if we have other option, but making a vertical model with no limited entry, it's wrong because in reality it's really a limited entry issue. So I don't want to go to using a vertical model because it's wrong. The correct one must use limited entry because we only have perforation of 6 feet, the interval with a thick reservoir. So let's just change it manually like this and neglect this hump. Okay, all right. Yeah. If we follow the hump, I rather use, yeah, this, I think it's okay lah. Okay, so yep, take it or leave it, but one thing that we can be sure of is that the permeability, looking at this one, will be high. Looking at the difference between the PWF and the built-up pressure, the permeability will be high. And another thing is that you must use you must include the vertical limited entry in this case because you have thick reservoir with a very small part of it perforated. Okay, so yeah, another thing that I can do actually, I can delete this section, okay, and change the duration of the build up. But yeah, I'm just going to maintain this data. I want to maintain this data, and I will recreate another model with shorter build up period where I already cut this section because it's it's wrong. This increase is wrong. It's because operational issue. Okay, so I think we can close. That's all. I hope you enjoyed this video. I hope this video is useful. Thank you so much for watching and see you again in the next Eng-Man videos. Thank you.